because you need to write a theory in the examination. So basic idea we must be aware of, right? So basically, depending upon the number of lone pair and sigma bonds, okay, you try to arrange them around the central atom, and so that you can minimize the repulsion between them. Okay. So if you have uh, two bonded electrons, two bonds, okay, that is going to be linear. The sp angle is 180 degree. This we have seen three will be trigonal planar sp2. Got it. 4, if you have 4 groups, it will be tetrahedral. Okay. Got it. Is that clear?
Yes.
Okay. So order of repulsion, lone pair repulsion is more than the lone pair bond pair. This we have seen. Okay. Next is suppose if we have 5 groups. Okay. What is going to be the hybridization? If we have 5 groups. Five means you need 1 S, okay, 3 P, okay, and 1 D.
Okay.
Got it? So you need 5 on the orbital in the hybridization. 1 S and all the 3 of the P orbitals, and you need, but by including all the 3 of the P orbital, you will have just 4 orbitals. You need D orbital also to get involved in the hybridization. Got it? And
Yes.
so the hybridization is going to be sp3d. Okay. Is that clear? So how it will look like if you have 5 groups? Okay. If you have 4, it will be tetrahedral. Okay. If you have 5, how it will look like? For the 5 groups. Any example you know where the 5 atoms are connected? PCl5. Got it?
Okay.
This is the best example. ASF5. Got it? So how the 5 groups are going to arrange themselves around the central atom? Like phosphorus is there. So 3 of them are going to be in a plane like this. This is trigonal planar. 3 of them in the plane, just like the blades of the fan. What is the angle between them? (120°). Okay. So if you see from the top, they will look like this. This is for the 3 groups, but we are not having 3 groups. How many groups we are having?
5.
We are having 5 groups. Got it? Is it clear?
Yes, sir.
Where you are going to put the 2 extra Cl, one at the top, another at the bottom. Got it? Is it clear or not?
Yes, that's good.
This is PCl5. Okay. Oh. So I hope this is what this shape is known as.
Mm.
Mhm. So suppose if I try to join the boundaries of the atoms, you have a base, triangular base, and one atom is at the top. Okay, if you try to connect the top atom to the corner atoms at the triangular base, you are going to have a pyramid at the top. Can you see this? A pyramid at the top and pyramid at the bottom. So it is, there are
Yes.
two pyramids. Okay. So, and with the base of those two pyramids, okay, the pyramids are like this. Okay. And the base is having three atoms. So trigonal bipyramid. Is it clear?
Yes, sir.
In short, it is known as TBP. Got it? Trigonal bipyramid. What are the values of the bond angle?
120.
120. The in the plane, the bond angle is 120, and between the top and the plane and the one in the plane, that is 90 degrees. Okay. These two
Okay.
bonds are known as axial bonds because they are along the axis. Okay. And these three are known as equatorial. Is this clear or no?
Yes, sir.
Axial bonds and equatorial bonds. Equatorial bonds mean the equator is in the middle of the earth. Okay, you know. So these three are equatorial bonds. Got it?
Yes, sir.
Axial and equatorial bonds. Axial bonds are longer. Okay, slightly more longer due to repulsion. Can you name the shape and the geometry, which I told you just now?
Trigonal bipyramid.
Yeah, trigonal bipyramid. Got it. Suppose if we have
Yeah.
in the five groups, suppose if one of them is lone pair. Okay, let's say suppose if you have sp3d, let's say suppose if you have sf4. Okay, is it like CF4 or methane? Is it like the methane or
Yes.
we need to check?
Yes.
Okay, suppose sometimes it appeared like methane. Okay, CF4 and SF4. You need to check in advance. Okay, you need to check in detail that how many valence electron the carbon is carrying. Carbon is having 4 electrons. Okay, first try to always before doing any question try to draw the Lewis dot structure. Okay, sulfur is there. Sulfur is having 6 electrons. Okay.
Okay, sir.
So if you have 6 electrons and 4 of them are used in making bonds with fluorine atoms. And you are left with one lone pair. So total how many regions of electron densities are there in single bond and the lone pair? How many sections of electron densities are there? 5.
One.
there is one lone pair and 4 bond pair.
Okay.
Got it?
Yes, sir.
One lone pair, 4 bond pair. Total how many? This is known as steric number.
5.
There are 5 of them. Got it?
Yes, sir.
So 5 of them. What is the ideal geometry for 5 groups? Just now we have seen trigonal bipyramidal. Now where should I keep the lone
Yes.
pair? Where should I keep the lone pair? Either
Axial bond.
either at the axial. Okay. The hybridization is sp3d. Got it?
Yes, sir.
So this is the Lewis dot structure, the one which I have written here, not the exact shape. Exact shape you need to uh, decide where should I keep the lone pair. Either we can keep the lone pair on the axial position. This is the vertical up and down are the axial positions. Okay.
Mm.
Or we can put the lone pair in the equatorial position. Okay, where should I put it?
Axial.
Yeah. So axial actually will cause more repulsion because there are 3 fluorine which are at 90 degree. Is it clear? Higher repulsions in axial lone pair. So we are going to keep the lone pair at the equatorial position. So this is incorrect. Okay, this was the possibility. Okay,
Mm.
and
Okay, sir.
this is correct. Got it? Is it clear or not?
Yes. Yes, sir.
So this is the actual shape. Okay, actual structure of SF4. I'm going to write it here also. But always start with drawing the Lewis structures. SF4 is there. So what this shape is known as? Is it trigonal bipyramidal? In shape, we will not consider the lone pairs. Got it?
Mm.
So is it trigonal bipyramidal?
Mm. No.
No. Its shape is like this. Or if you make it like this, what this shape is known as? Seesaw.
The triangle.
Yeah, seesaw. Just look at the bond. Don't look at the lone pair. Look at the bonds. How they are like? They are like this. There are 2 bonds up and down. One in the front, another at the back. Okay. Like this, one like this, another like this, and 2 are the got it. So make it
Yes.
like this. Okay. So the 2 are pointing downwards. Okay, like this. So it is like a seesaw. Okay.
Yes.
This shape is known as seesaw. Okay. So you have seen it in the gardens. Okay, kids play around with it. Right, seesaw. So I hope you remember it.
Yes, sir.
Okay, now you have suppose in 5 groups there are 2 lone pairs and 3 are bonds. So what is going to be the shape, exact shape of the molecule? For example, let's say I take ClF3. So how many electrons, valence electrons Cl is having? Central atom is Cl. Got it?
Yes, sir.
So how many electrons does Cl is having?
Seventeen.
How many electrons, valence electrons Cl is having? Halogens.
7.
7. Yes, exactly. So first try to draw the Lewis dot structure. So how many are bond pair? How many are lone pair? 3, 4, 5, 6, and 7. There are 3 bonds with 3 fluorine atoms. Got it?
Yes.
Try to figure out the. There are 2 bonds, 3 bonds, 2 lone pairs. So you have 5. Got it? 5, that ideal base geometry is diagonal bipyramidal. And I told you where to put the lone pair.
On the
In the
equatorial.
equatorial plane. Okay, in trigonal bipyramidal, always put the lone pair in the equatorial plane. So it is going to be like this.
Yes, sir.
So we were having 2 bonds like this, but now we are putting the lone pairs. The shape of the molecule is going to be, the shape is like this. Okay, and if you make it like this, it becomes a T. Got it? T shape. Okay. Hybridization is
Okay.
sp T T, and this is going to be, because we don't consider lone pair because there is no atom on the other side of the lone pair. So we don't consider the lone pairs in the shape. It is T shape. Got it?
Yes.
Now suppose if you have XCF2, how many electrons xenon is having? 8 electron because it is a noble gas. Okay. Xenon is a noble gas, so we have 8 electrons. How many are participating in bond? Okay, I need 2 of them, 2 electron, 1 each in making 2 bonds. Got it? So we are having 3
Yes.
lone pairs and 2 bond pairs. Got it? Total, how many? 5 of them
Yes,
are there.
sir.
Right? Hybridization is going to be same. sp3d. Okay. And XCF2, where am I going to put the lone pair? The 3 lone pairs. The base arrangement of the electronic pairs will be that trigonal bipyramidal only, but in shape, while telling the shape, you will not consider the lone pairs. Got it? Lone pair you are not going to consider. So X is there, okay, and 5 of them are there, right?
Yes, sir.
Where should we put the lone pair?
On the equatorial.
In the equatorial plane. Got it?
Yes, sir.
So what is the bond angle?
3,
Hmm. In this case,
120 and 90.
180. Got it? What is the shape known as? Linear shape. Getting my point or not?
Yes.
Linear shape means this is straight molecule. Okay. Is it clear?
Yes, sir.
So this I hope is clear. Now we move on to the groups having 8 electrons. Okay, this 8 steric number 8 and not 8, 6. Okay, we were at 5, so now we will move on to 6. Okay.
Yes, sir.
6 means let's take example of SF6. So SF6 is sulfur is having 6 valence electrons and all 6 of them are participating in the bond formation. Okay. And
Yes, sir.
because all 6 of them are participating in the bond formation, there is no lone pair. What is going to be the hybridization? Hybridization, we need to take 6 orbitals.
Mm,
Got it?
Yes.
In the hybridization, starting from S. Got it?
Yes, sir.
So S, I will take P also, all the P orbitals and D. Two D orbitals I need to take, 2 of the D orbitals.
Mm,
Got it?
Yes. Yes, sir.
So sp3d2. So when you will have that sp3d2 hybridization, when you have 6, steric number as 6, getting my point or no?
Yes, sir.
If the steric number is 6, then the sp3d2 hybridization. Okay. And how it will look like? What will be the arrangement of 6 groups around the sulfur? The shape.
Mm, Like 2 will be the axial and
Yeah. 2 of
4
them are up and down. Okay. And 4 of them will be,
equatorial.
yeah, but here you don't call equatorial and axial because all bond angles are same. There the bond
Okay.
angles were different. Okay, if all the bond angles are 90. Okay, this is also 90. This is also 90. So they are same. Okay. And this geometrical arrangement is known as
90.
hmm, this is known as
90.
octahedral.
Mm,
So you may be getting confused that if you have 6 bonds, how come it is octahedral?
Yes, sir.
Octa means 8, but you have 6 groups. Okay. So Suppose if you try to enclose it in a wall, okay, in walls by surrounding it by walls, okay, this one. Got it?
Yes.
Can you see I have enclosed the structure?
Yes, sir.
So there are four faces, triangular faces, okay, two like this and two like this. Can you see? This face, this
Yes, sir.
face. One is at in the front of us like this, and another is back, which is not visible to us. Okay. Similarly, this face, one face towards us, this on the side, this on the other side, and one on the back side.
Mm.
Is it clear or not? So
Yes.
so eight faces are there. Why? Student may get confused. Octahedral means six, but eight bonds. No. How many bonds are there?
Six.
Octahedral means how many? Six bonds. Okay. So
Yes, sir.
sp3 for hybridization six bonds. So, but if it has six bonds, how come we have? How can we have that octahedral? Because if you enclose that structure by connecting the corners, you will have a body which is having eight faces. Okay, that's why the name octahedral is given. Is it clear or not?
Yes, sir.
Got it? So
Yes, sir.
octahedral SF6. Okay. And suppose if you have one lone pair, okay, like BRF5. So we will try to draw the structure of BRF5. So BR is having 7 valence electrons. Got it?
Yes, sir.
So how many bond pair and lone pairs are there?
5 bond pair and 1 lone pair.
5 bond pair and 1 lone pair. Yes. Hybridization is going to be same. We have 5 bonds and 1 lone pair. Got it?
Yes, sir.
So lone pair we can, in this there is no axial equatorial, we can keep it because all angles are same. Adjacent angles are 90 everywhere. This is also 90, this is
Okay.
90, this is 90. So no need of calling it. But for the sake of symmetry, we will put the lone pair either like this or this. Okay. Either up or either down. But there is nothing called axial equatorial. Students get confused in when they compare with TBP. TBP call it axial equatorial. Okay, but in this there is nothing called axial equatorial. All positions are same. But for the sake of simplicity, okay, to make us understand in a better way, you can put the lone pair like this, either up or down. Got it?
Yes, sir.
So these 5 of them are in the plane with one at the
Yes, sir.
top. Earlier we were having one at the top, another at the bottom, but now at the bottom we have placed the lone pair. So tell me what is going to be the shape known as? What this shape is known as? Yeah, what this shape is known as? Yeah, shape is known as.
These 5 faces.
This
Oh,
shape is, if you consider, is known as Okay. It is one lone pair is there. Okay. So, but it is now not
Yes.
on. Okay. This is square pyramid. Okay. This has become a pyramid with a square base. Okay. Is it clear?
Mm, yes, sir.
This is square pyramid. Got it?
Yes, sir.
I hope this is clear to you.
Yes,
Got it?
sir.
Okay. What are the bond angles? Are they perfectly 90?
No.
No, they are not perfectly 90. Why? Is this
Yes.
90?
Mm,
They were 90 at SF6. Are they 90 in this also?
mm,
They are less than 90. Why?
mm,
Because this lone pair, bond pair repulsion is more than the bond pair repulsions. A lone pair is pressing these four bonds upward, okay, slightly upward, because lone pair is occupying more space, okay. So this bond angle
okay,
is
sir.
79 degrees, okay. It is somewhere around less than 89, not 79, 89 degrees, okay. Less than 90 degrees.
Okay.
So this shape is known as distorted. Distorted square pyramid. Got it?
Yes, sir.
Suppose if you have seven, I told you IF7. Okay, that is SP3D3. Hybridization IF7. Okay, it is pentagonal bipyramidal because five of them you are going to put in the plane, right?
Yes, sir.
One at the top, another at the bottom. These are the axial bonds. Okay, like this pentagonal. What are the bond angles?
These are all 90.
Hmm. Pentagonal bipyramidal, the bond angles in the plane is 360 by 5. It is 72. Okay. Pentagonal mean the base is pentagon and there is one top and this is 90 degrees. Got it?
Mm,
Now we will take the two examples. Okay. One is XCF6. Another is XCF5 minus. So whenever there is minus, put one more extra electron on the center line. And whenever there is a plus, okay, put less electron, one electron, or as per the positive number of positive charges, put that many electron less. Okay. XCF6 xenon, this is neutral. There is no charge. How many electrons are there on the xenon? 8 electrons. 6 are bonds. So two will be left, two electrons will be left alone. So there is going to be one lone pair and 6 bond pair. Is it clear?
yes,
And
sir.
this is same as that of 7, steric number 7. Okay, 7 is on that SP3, E3 hybridization. But the lone pair, where should we put? The lone pair, actually, there is a slight change in it. The F occupies the octahedral arrangement and the lone pair emerges from between. Okay. So this is known as distorted octahedral. Okay. This lone pair emerges from the middle. Next is which I told you, Xe, this is very important, XeF5 minus. So try this. So how many electrons will you consider on the xenon?
Seven.
Minus is there. Minus means more electron or less electron? Minus means more.
More.
Got it? More number of electrons.
Yes.
So clear or not?
Yes,
So
sir.
how many electrons are more than the normal number of electrons?
One.
One electron extra. So total electrons are 8 plus 1. 9 electrons. Okay, on the xenon. If you have minus, put that many extra electrons, which is equal to the number of negative charges. If you have plus, then put that many extra remove that many electrons, which is equal to the number of positive charges. Got it? XeFi minus to 9 electrons. I need 5 of them to make bond with the fluorine. Okay, how many are left? 4 are left. Got it? 5 of them are
Yes, sir.
required for bonding with each one with fluorine. 5 fluorine atoms are there, and there will be 2 lone pair. Got it? 2 lone pairs will be there. Got it? So I can write it 2 lone pair and 5 xenon fluorine lone pairs. Is it clear or not?
Yes, sir.
So, and there are how many electrons? There are total, and the hybridization is because there are 7, total 7. So, 7 orbitals are going to come up sp3d3. Okay, 6. You need 7 orbitals. One is 3p and d3. Okay,
Okay.
you undergo intermixing or hybridization. Okay, 7. What is going to be the shape? There are 2 lone pairs. So out of 7, if there are 2 lone pairs,
6.
so 5 bond pairs. Lone pair should be farthest from one another. Got it?
Yes, sir.
Why they should be farthest from one another?
Because they
They repel each other.
repulsive.
Got it? So how you are going
Yes.
to put the lone pair? Opposite to each other. Okay. And the 5 fluorine atoms are going to get arranged in the plane.
Okay, sir.
So what is going to be the shape of this molecule? In the shape, don't consider the lone pairs, because you do not have any atom on the other side. They are like this. 5 of them. Can you see?
Second.
Yeah.
Yes, sir.
Pentagonal planar. Okay. Is it clear?
Yes, sir.
Okay. Let's try to do one question, and then we are going to move towards the other part of the VSEPR. What is the shape of XeF5 plus? XeF5 plus. Shape, geometry, and hybridization. XCFI plus. Xenon will have how many valence electrons?
8.
8. But this is plus. So how many valence electrons?
2. 9.
9 or 7?
7.
8 minus 1 plus 1 and then a 7. Got it?
Yes,
Is it clear? Out of
Yes.
7, out of 7, 5 of them are given 1 each to 5 fluorine atoms. Got it? And 2
Yes, sir.
remains as lone pair. So 1 lone pair, and there are 5. Is it clear or not?
Yes, sir.
So what is going to be the hybridization? Can you tell me quickly? Look, there are 5 electrons and 2 electrons in 1 lone pair. Okay, is it clear? So 7 electrons are there.
Yes.
So what is the hybridization?
Yes.
Hmm.
6.
How many groups? 6. Okay, so hybridization is going to be is it sp3, sp3d, sp3d2, sp3d3?
SP3D.
Yeah, sp3d2. Okay, because 6 are there total. Steric number is 6. Steric number is the sum of the single bonds and the lone pairs. Got it? Are you
Yeah.
getting my point or not?
Yes, sir.
So 6 are there, sp3d2. Okay. S, there are 3p, 2d, 6 of the 6 of the orbital I need to take. Okay. And what is going to be the shape? Ideal shape of 6, steric number 6. That was octahedral. Okay.
Yes, sir.
But now we out of octahedral, there are only 5 bonds, and there is 1 lone pair. Lone pair, in this case, you can put it anywhere, but for the sake of simplicity, either show it in upward position or downward position. So what is the shape of XCFI plus?
This dot square pyramid.
Why distorted? Because the lone pair is going to push these 4 fluorines upward. Okay.
Okay.
Is it clear? So first you
Yes.
decide the, is it clear or not? Bond angles will be less
Yes,
than
sir.
90 degrees. So what you do, you make a base geometry from, suppose if there are 2 linear, if there are 3 trigonal planar, if there are 4 tetrahedral, if there are 5 trigonal bipyramidal, okay, and if there are 6, is it clear, octahedral, if there are 7 pentagonal bipyramidal, and if there are lone pairs, okay, first to count the lone pair, first to count the bonds and lone pairs, sigma bonds and lone pairs, okay, and accordingly you put the
Yes,
lone
sir.
pair in these, okay. Is it clear or not?
Yes, sir.
Got it? Distorted square pyramidal geometry. I hope this is clear to you. Got it?
Yes.
Next is how the VSEPR theory help us to decide the bond angles. With the presence of lone pair, what happens to the bond angles?
It will get bigger.
The bond angle get reduced or it will become more larger with the presence of lone pair.
Lone pair is larger than bond pair.
So this is the very important point of the VSEPR theory. Okay, that is bond angle will be reduced in the presence of lone pairs. Why? What justification you are going to give? Because the lone pair, it is not having other atom on one of its sides, so it occupies more space. Okay, it causes more repulsion. Or we can say a very famous point of the VSEPR theory that the lone pair causes more repulsion and lone pair bond pair repulsion is greater than bond pair repulsion. Okay, so lone pair actually compresses the two bonds. Is it clear?
Yes, sir.
Suppose I give you the example of methane. All bond angles were exactly equal. How much they were? 109 degree 28 minutes, okay, or 109.5 degrees. Suppose if you put in one lone pair, the steric number which is equal to the sum of sigma bonds and the lone pair is still the same. Got it? What happened to the bond angle? Will it be more or will it be less?
Yes.
Less. Why less?
The repulsive force makes it smaller.
Yeah, because the repulsion caused by the lone pair, okay, suppresses the bond angle and the bond angle is reduced. Okay, lone pair bond pair repulsion is more than the bond pair repulsions. Is it clear or not? So it
Yes,
changes
sir.
to 107.2 degrees. Got it? 107 degrees you can write.
Yes.
Suppose if we take water, okay, water we have two lone pairs, oxygen. The hybridization is same, okay? It's
Okay,
same
sir.
everything. Okay, and the bond angle, because there are two lone pairs, they are going to put more pressure on the. So this bond angle is reduced further. Is it clear or not?
Yes, sir.
The hybridization is same because the steric number lone pair bond pair sp3, sp3, sp3. Okay. The
Yes, sir.
shape is tetrahedral. The shape is pyramidal. And this is bent V shape. Got it? Is it clear or not?
Yes, sir.
Next is, can you compare the bond angle of NH3 and NF3? And with this example, we are going to discuss one more point of VSEPR theory. Can you compare the bond angle between NH3 and NF3?
Just subtract.
NH3 is this. Okay. They have one lone pair. Okay. Same. How will you
We
compare
will
the
say by the amount of lone pair.
lone pair are same. Okay, there are three bond pairs. Lone pair bond pairs are just the same. How will you compare the bond angle? Okay, so there is a one point which says bond angle decreases with the increase in electronegativity of the subsequents of the groups. Got it? So by reading this statement, can you tell me whose bond angle is going to be smaller? Who is the most electronegative element of the periodic table? It is the fluorine. Okay. And
Yes.
electronegative subsequent has a large tendency to pull the electron. Now look at this very carefully. Okay. Suppose in the electronegativity values are just assigned, these are just numbers, okay, that help us to know that who is more tendency to high tendency to pull the electronegativity of hydrogen. Okay, it is 2.1. Electronegativity of fluorine is 4, which is the most electronegative element. Electronegativity of nitrogen is 3.0. Got it?
Yes, sir.
Is it clear or not?
Yes, sir.
So now in the case of ammonia, who is more electronegative? Nitrogen or hydrogen?
Mhm.
N or F? N or H?
Yes.
N is more electronegative. So if it is more
And
electronegative, the bonded electron pair are going to be pulled more towards the central atom. Can you see
yes,
this diagram? Can you see this diagram? What I am putting, why I am putting these dots? What these dots represent? These dot represents the bonded electron pair between the nitrogen and the hydrogen, and they are more towards shifted more towards the nitrogen. Why is it so?
electronegative.
Because nitrogen is more electronegative. Okay, and if they have come closer to it, closer, what will happen? Look, all the electrons are moved towards nitrogen, so more repulsion is going to happen. the bond angle will be more, and it is 107 degrees. Is it clear or not?
Yes, sir.
What happens to NF3? If you look at the bond between nitrogen and fluorine, who is more electronegative?
Fluorine.
F is more electronegative. So the bonded electron pair are going to be like this, or like this. Which is the correct option? Are they going to get shifted towards the nitrogen or the fluorine?
Fluorine.
Yeah, fluorine, because fluorine is more electronegative. Got it? So what will happen?
Yes, sir.
Because the substituent is more electronegative, the bonded electron will be taken away by the substituent farther from the central atom. Repulsion will be lower and the bond angle will decrease. So this is a very important point of VSEPR theory, that the bond angle will go down if the electronegativity of the groups is decreasing. If the electronegativity of the group increases, okay, decreases with the increase in electronegativity of the substituent. Okay, is it clear? There is one more very
Yes,
famous
sir.
question which asks us to check the polarity or the dipole moment of NH3 and NF3. Or we can compare this with the dipole moment. Just a second. Let me take one more example. Okay, this bond angle is 102. Got it? It drops. Okay. So if central atom is more electronegative, okay, the bond angle is going to increase. Okay, compare the bond angles of these are one below another, they have same number of valence electrons. The substituent is becoming bigger and bigger. NH3 like this. Got it? PH3 is like this. Why PH3 is bigger? Yeah, Nabila.
It has more electronegativity than H.
Because of what? Because of the third.
Electronegativity.
It is a third period element, right? And ASH3 is fourth period element. Got it?
Yes, sir.
Substituents are just the same. Arsenic. Okay. Are you getting my point or not?
Yes, sir.
SbH3 is further bigger. Okay. The groups are same. What will happen to the bond angle? Suppose if you have a small atom, bigger atom, bigger atom, bigger atom with same hydrogens, is there going to be more repulsion or less repulsion between the hydrogens?
More.
More, where it is the most, where the repulsion is going to be the maximum between the hydrogens. There are three hydrogens everywhere. Are you getting my point or not?
Yes.
Everywhere you have three hydrogens. So where the repulsion is most, maximum. I can give you a hint. wherever there is a less space, wherever the atoms are closer, the repulsion is going to be maximum. I hope you also agree with this point.
Yes, sir.
Okay, so can you tell me where the repulsion is most maximum?
S3.
NH3 or SbH3? The first one or the last one?
Last.
First one, the repulsion is, look, they are very close to each other. Got it? Getting my point or not?
Yes, sir.
So they are very close. Very close means more repulsion. More repulsion means bond angle will spread. Is it clear?
Yes, sir.
Will expand. I hope it is clear to you. Okay. So if the bond angle is compared, okay, the ammonia will be like this. It will be bigger, larger bond angle. The hydrogen will move apart because they are on the smaller atom, more repulsion. Bond angle will decrease. NH3, PH3. Bond angle, I hope you understood this one. Got it?
Yes, sir.
Okay. PH3, AS, HC arsenic. Okay. Antimony. Antimony is further bigger, means bigger. So same three atoms are there, but they are too far. One is on this side, another on. So same three hydrogen, but the central atom has increased its size. So lesser repulsion. So bond angle decreases. Is it clear or not?
Yes, sir.
With the increase in size of the central atom. Okay. Now, for example, H2 and H2S. Whose bond angle is more? Oxygen and sulfur, the central atoms are one below another.
Also,
Hmm.
sulfur.
Hmm. Where the bond angle is larger.
H2S.
H2. Yes. Why?
The group is.
Oxygen is smaller atom, second period element. Got it?
Yes.
So smaller atom, the hydrogen will be close and they will try to move apart. Sulfur is a bigger atom. Okay. So there is more space. Even if you put two hydrogen, okay, they will be far apart because the central atom is bigger. Got it? There will be less.
Yes.
So bond angle will be higher for smaller atom. Got it? Is it
Yes,
clear?
sir.
Now OH2O and OF2. And this is the drawback of VBT.
Hmm.
They are same. Okay, this is the structure of H2O. This is the structure of OF2 isostructure. And this is the structure of OCl. So tell me. Getting my point or not?
Yes, sir.
So what I said about first, tell me this, these two.
So
Where the
we
bond
will
angle
have
is
more
more.
than anything.
Pardon? Where it will be more? Central atom is same. Okay. And the electronegativity of the groups is changing. Okay, electron F is more electronegative. Getting my point or not?
Yes, sir.
In this case, oxygen is more electronegative. Look, I put the arrows to show you where the electrons are getting pulled. Okay. So electrons are pulled towards single atom oxygen because oxygen was more electronegative than hydrogen. What will happen to the bond angle? It will expand,
Mm,
will widen up. Why? Because the electrons are moving closer towards the oxygen. They will move up. What will happen to OF2? The bond angle will decrease. Got it?
Yes, sir.
Why? I told you the bond angle decreases with the increase in electronegativity of the substituent. Chlorine being more electronegative will pull the electrons away. Less repulsion. In this case, the repulsion is going to be more. But what happens is VBT is not applicable for the molecules which have bigger substituents. Here also the bond angle should be low because chlorine is electronegative. But to our surprise, the bond angle is much larger. So chlorine was also electronegative, but all of a sudden what happens? Actually, the size of the chlorine is much larger. And they can't reduce their bond angle, they have lone pair, so repulsion has taken place. Is it clear or not?
Yes.
So bond angle will decrease if you have electronegative substituent.
Mm,
Electronegative groups or substituents. Nabila, is this clear or not?
Yes, sir. So it decreases when higher electronegativity is there.
Yeah, it decreases. So electronegative groups will reduce the bond angle.
Okay.
But suppose if the groups are from the third period, okay, if they are from the third period, the groups will be bigger in size. So bond angle, if suppose I can't reduce further because these groups are so large, got it? They can't come close. So bond angle is larger. So this is the drawback of VBT, VSEPR theory.
Mm.
So bond angle is more than that of water because of the bigger size of the substituent. I hope it is clear to
So
you.
this drawback is, yes, sir.
Drawback
The drawback is only
means,
at group 3.
yeah, VBT is not able to predict some of the drawbacks. Okay, it is not able to predict the magnetic behavior correctly. It is not able to predict the bond angles correctly if you have very big atoms. Okay, or bigger atoms, the bond angle is not as per the expectation. where the steric repulsion is very, very high. Got it? Is it clear or not? Any doubts in this?
No.
Now we are going to discuss dipole moment. So what do you mean by dipole moment? What are the units? Dipole moment. Dipole moment is a measure of polarity of the molecule. How polar? What do you mean by polar? Something which is having opposite charges. Got it?
Okay.
So that is called polar moment. Okay. And dipole moments help us to determine the polarity. Got it? Of the molecule,
Yeah.
right?
Yes, sir.
How the polarity is determined by the charges. Got it? Is it clear or
Yes,
not?
sir.
So by the charges, not only by the charges, but by the also by the distance between them. Okay. Suppose if there is a positive charge and a negative charge separated in a molecule, okay, we call it polar molecule.
Oh, okay.
Okay, and this is charge Q and minus Q, and the distance is D. The overall polarity is how it is measured. It is measured not only by the charge, it is measured by multiplying the charge with the distance between them. And it is represented by mu. Mu is the symbol for the dipole moment. Is it clear?
Yes, sir.
Suppose if you have the same charges, plus Q and minus Q, separated at a larger distance, through a larger distance. So where the dipole moment is going to be more, and which molecule is considered to be the more polar? The charge is saying only the distance has increased.
Mm. The more distance, the more polar.
Hmm? Which one is more polar?
The more
The right one or the left one?
the right one.
Yeah, right one is more polar. Why? The charges are same.
The
Why more
distance
polar?
increases the polarity.
Yeah, exactly. The distance is more. So same charges at more distance are going to be more polar, considered to be more polar. Got it? If the distance is same, the charge is more, so that is more polar. Got it?
Yes, sir.
Is it clear or not?
Yes, sir.
So
Mm.
next is, it is a vector quantity. So there can be multiple polar bonds in a molecule. And the overall dipole moment is the vector sum of the dipole moments of the individual bond inside the molecule.
Okay.
What do you mean by vector?
Vector.
Vector quantity means it has a direction.
They have. Yeah, yes.
And the direction need to be it is represented like this, okay, from positive to negative, because this charge has generated when the positive charge has moved towards the negative charge. So it is represented, the direction is indicated by putting an arrow from positive to negative. This arrow, can you see the tail of the arrow? It has a, it is look like a positive charge.
Yes, sir.
Okay, it represents that the electron has moved from a positive to negative. Okay, move. That's why the direction, the movement of electrons. Okay, this is the direction. Got it. Wherever the electron goes, they do have negative charge, and from where they come, there you have positive charge. So the dipole moment, the direction of the dipole moment is from positive to negative. Got it.
Yes, sir.
I hope it is clear to you. Okay.
Yes, sir.
Is directly proportional to the charge and the distance between the molecule. Okay. The polarity, suppose CO2 molecule is there. What is, how many sigma bonds are there?
One,
One
two.
sigma and five. The geometry of the molecule is, and hybridization is decided by the sigma bonds only. What is the hybridization of this?
Mm, um, SP.
No, it is SP. Exactly. Because there are two sigma bonds. Got it?
Yes, sir.
It is clear or not?
Yes, sir.
So
Mm,
SP hybridization is there. Okay, and the polarity. This is not. This doesn't have complete charges though, like plus and minus, but partial charges will be there. Why there will be partial charges? And which atom will have the positive charge and the negative charge?
mm,
The oxygen is more electronegative. So what will happen? This electron will be pulled towards the oxygen. Not completely, they will be in the bond only, but slightly more towards the oxygen. So oxygen will acquire minus charge, slight minus, and this will acquire positive charge. Similarly, the other carbon sp, what is sp? The bond angle was 180. Okay, that we know. We have seen the two groups are there. Okay, this is also positive and negative. Got it?
Yes, sir.
Is it clear? So the dipole moment of this direction is from positive to negative. Is of this bond is from this. Okay, and the dipole moment of another bond is also from positive to negative. Got it?
Yes, sir.
Both the dipoles are equal because both on both sides you have oxygen atom. Got it?
Yes, sir.
Is it clear or not?
Yes, sir.
So what is the overall polarity? You have two polar bonds, but because the dipole moment is a vector quantity, the overall dipole moment is the vector sum of the two dipole moment vector sum. Okay, this is going to be 0.
Okay.
Non-polar molecule. Why?
Vectors Q plus D is the opposite, so negative and positive will cancel.
Because they got cancelled. They cancelled each other. Got it?
Yes, sir. Yes, sir.
The vectors cancelled each other because they were of equal size, equal magnitude. Is this clear or not?
Yes, sir.
So non-polar. Oh, so overall polarity of the molecule, polar bond doesn't mean the molecule will be polar, because you need to take consider the dipole moment with the direction for each and every bond, and for total molecule the dipole moment is the vector sum of the dipole moment of the individual bonds. Okay. And if these dipole moment cancel each other, that means the molecule is non-polar. They will cancel each other if they are equal in and pointing in equally in opposite directions, and the resultant dipole moment is going to be zero. Is this clear or not?
Yes, sir.
Okay, what is the unit?
Not sure.
Unit is actually the unit of charge and distance. SI unit.
Joule.
Coulomb meter. Got it?
Okay.
Coulomb meter means the charge is in coulomb and the distance is in meter, but actually this is a very big unit.
Mm.
Why?
Coulomb is
It is a very large unit. It is because the meter you don't have the size in meters. Got it?
Mm.
Are you getting my point? So you have a
Yes, sir.
small unit. Okay, and that is debye.
Debye.
Yeah. It is represented by the symbol D. Okay.
Okay.
So 1 debye is very small, and if you compare it with coulomb meter, it is 3.33. 56 into 10 to the power. Very, very small unit, minus 30.
It's constant.
Yeah, 1 debye is a very small unit, 3.33. Okay, you can leave the rest of the digits. Okay, 3.33 into
Okay, sir.
10 to the power minus 30 coulomb meter. Is it clear?
Yes, sir.
So this is used to express the dipole moment of the molecules in debye. Okay, linear molecules
Okay, sir.
will have zero dipole moment. And if you have the overall dipole moment is the vector sum of the dipole moment of the individual molecules. So we will try some questions on the dipole moment, and then we are going to move towards the molecular orbital theory. Is it clear?
Mm.
Okay, this is the next theory
Yes, sir.
which help us to understand how and why the molecules participate in bonding. Okay, that is a more accurate theory than the VBT. As of now, we are doing the VBT, valence bond.
Mm.
We are going to discuss the one more just small question. What is going to be the dipole moment of H2 Cl F2 Cl2? It is going to be 0. Okay, because they are
Uh,
non-polar molecules. Is it clear now?
Yes, sir.
Why? Because they all both the atoms have same polarity. And if both the atoms
Yes,
have
sir.
same polarity, there will be no charge arising on any of the atoms. Okay, it will be non-polar.